In this presentation, we will learn CFD modeling of erosion and accretion rate and its industrial application. We will also learn basic equation and tutorial using ANSYS FLUENT. Erosion is happen when fluid flows with particle, and this particle interact with wall surface of pipe, and due to im, im, interaction with wall surface, it results in wear of surface, and the material removal rate is presented using erosion rate, that we will learn using a mathematical function in this uh, presentation. Erosion rate is determined at all surfaces, and erosion rate is defined using this expression, and erosion rate is directly proportional to the velocity of particle. When all particles are in, when all fluid particles are impinging on the solid surface, then there is a material removal rate, and that is determined using the function of erosion rate. It is the summation of material removed by all the particles, and it is a function of mass of particle, particle diameter function, and angle function. The angle of particle toward the surface is also important to determine the erosion rate. The erosion rate is also depend on the relative particle velocity and surface area of target material. And this equation is solved in CFD solver coupled with DPM model that we will learn at the end of this tutorial. The second term associated with erosion is accretion rate of particle. When fluid flows with particle, take an example of air breathing with dust particle, and this dust particle accumulate inside the surface of oesophagus, and this accumulation of particle is called as accretion rate, and it is proportional to the mass of particle, mass flow rate of particle near the surface divided by the surface area. In CFD modeling, particle erosion rate and accretion rate are coupled with solved to find out the erosion rate. Erosion rate modeling is essential in many industrial applications to predict the maintenance and failure of parts. For example, in oil and gas industry, pipeline erosion is very essential, and it is also essential in a downhole tool and equipment. Erosion modeling is also important in aviation and aerospace industry to determine the, the erosion rate from the jet engine component and selection of right material for less maintenance and to prevent its failure. Erosion modeling is also essential to predict the maintenance need from ship hull offshore platform. We also observe erosion of river sand near the coastal area, and dust particle also cause erosion of infrastructure, and that is also determined by using uh, CFD, and it is also used in mining and mineral processing industry. In manufacturing process, erosion is very essential to determine the material removal rate due to the high velocity water jet along with abrasive particle, and, erosion modeling is essential in heat exchanger and boiler to determine the failure of pipeline. In power plant, there are a lot of pipes are there to carry the coal and air. This air and coal is carried from the mill to the furnace, and this particle causes the corrosion near the corner of coal pipe, and this can be determined using the CFD simulation to predict the failure of coal pipe in power plant industry. What are methods to determine the erosion rate? Apart from experimental method, there are various methods for erosion modeling using CFD, empirical model, multi-phase model, and finite element method. And CFD is helpful when particle is carried by fluid and it interact with solid surface. And, and the interaction between fluid and surface can be modeled for the a single phase and multi-phase flow in industrial application like uh, cement industry, power plant industry. And finite element method is also helpful to determine the state distribution and material wear rate in complex geometry. Now, what are variables affecting the erosion rate? When particle flows toward the surface at an angle alpha, then there is a possibility of material removal rate. This angle is also one of the factor to determine the erosion rate, and erosion rate is also affected by the impact velocity, particle diameter, particle mass, collision frequency between particles and wall surface, and erosion rate also depend on the material properties of particle and solid surface like hardness, density, and the coefficient of restitution of solid particle and collision is also important, and the effect of angle of impingement decide the material rate from brittle and ductile material. At a lower angle, the material removal rate is high for the ductile material, but for brittle material, the removal rate is high when these particles are impinging normal to the surface. Here we can see the how material removal rate is observed at the lower angle and higher angle. Erosion model for the dense system, when is coupled with DPM model, then total erosion rate is equal to the erosion rate due to the wall shear stress and an erosion rate by the solid particle motion near the moving wall. This way we can find out overall erosion rate. Erosion rate depend on the particle and surface material properties, and there are also other properties like properties of the fluid, work hardening, and ambient temperature. During the CFD modeling, we can consider the various factors in erosion rate like impact condition, angle of impingement, and hardness is also accounted in the function of erosion rate. Erosion rate is determined by the particle characteristic, In this tutorial, we learn how to determine the erosion rate using this elbow-like pipe. First, create the geometry in the space claim. First, take the plane uh, and then take a sketch plane. See here we can create a sketch plane and draw the model whatever you like line, and then after that you can make a curve here. First make curve, then after that we can extrude the surface. This is surface is there. We can pull using the strip command. Using the strip command, you can strip this curve. This is the command is there. Using a sweep option, using this command, we can just sweep along this curve, and then you will get the solid model like this way. Once this solid model is created, then you can open this model in the meshing platform is there. There is a meshing platform is there, and then you can open in the meshing. And here we can set the parameter for the fluent, for resizing the element. Give the body mesh size 1.5, inflammation is the 5, multi-zone, this is the inlet, this is outlet, and this is wall. Then right click here, generate mesh, and then you can see the how mesh is look like this. Once meshing is over, then you can export the file. Then you can export this file to the erosion pipe. Once the export is complete, then you can open the ANSYS FLUENT. Then solution, start. You can close this one. We cannot open multiple license. Start. and then read the mesh file. Go to general setting, then check the scale, all in meter is okay. Gravity you can set it as a 9.81. You can see the 9.81. You can see here viscous model we can use as a case pulling realizable model. And here we see how it is a model looks like here. Here we can define as the mass flow rate. Here we can define as a velocity as a 0.25 or zero point 0.5 meter per second. Outlet you can declare as a pressure outlet, and initially we can run method we can use as here, use as a simple, and run for at least 600 iteration. Initially just run for the 50 iteration for the single phase flow, then you can add particle. Just stop it. Here residual you have to set to be the lowest for better convergence. Here you can run further for further convergence. Then in model you can set here interaction with we can avoid, unsteady particle you can set here. Here you can see the erosion model. This is the erosion model. Here you can consider here. Okay. Then injection, you have to inject the particle from the surface, and which is the surface inlet. Here you can inject normal to the surface. We can decide diameter 0.1, velocity we can define as the velocity will be 2.5. Particle flow rate we can keep as low as possible. Physical model, other physical model we can avoid, and take as this is as inner particle. Total mass flow rate we can assume as a very small. Particle distribution we can also give, you know where. And after that we can see what is the frequency. And here you can select at the interval is a 10, and then run it, and you can see the boundary condition at a wall. And you see these are the erosion model are available. You can see what is the generic model, what is the Finney model, what are Mac Lowry model, Oka model, DNE model. You can select there is also panel. What is the impact angle? Here we can also define the impact angle, their function, minimum, maximum. Here we can also give the some curve. If you are interested, you can give some curve by defining the this polynomial coefficient. If you don't have, you can neglect. Just close it. Each model, here is a Finney model. Finney model has some model constant, velocity exponent. Like this is the erosion rate is directly proportional to the velocity of particle raised to power n, and this velocity exponent you can give, and this is generally true for the some surfaces like stainless steel. And angle of maximum erosion degree we can also give here. Then this is also one model is there, McLaury erosion model, defining this some model constant, velocity exponent, and this is also DNA model, Oka model. Just apply it, and inlet that will be the DP will be the escape. Same for the outlet. Here I am defining the gauge pressure 0 and just run it. Here we see the DP mutation is solved. It may take time. For the simulation, yes, it is taking time. At least 5 to 10 DP mutation should be the computed, so that we can see the particle erosion rate. Here it is taking time. Because this is a two-way coupling, hence it is a taking time. And here you can see the contour, DPM source, and here you can see the DPM variable. You can see the here DPM erosion rate by using the different model. Here you can see the how much is the erosion rate. You can see the erosion rate is maximum at this surface. You can see more clear how much it is there. That we can see this is the erosion rate is there. This way you can model as the erosion rate. And that means this particle is causing the erosion rate at this surface. We can see the erosion rate is high this way, and this is always measured in kg meter per square second. If you want to convert erosion rate into the mm of per year, then you can using custom function dpm variable. You can consider the dpm. You can take any dpm corrosion rate. Select here. Then divide by the density. We can take a density of properties. Then you can divide by density, multiply by uh, 365 multiply by 24 and multiply by the 3600. Then we can use a particle erosion rate per mm per year. And I think this is quantity in kg per meter square. How much particle is material is removed in mm. Mm is we can divide, we can get in mm, meter per year. Just define it, and you can see here in custom function this quantity in is 9 into 10 to the power minus 10. That means you can see that is very low. This way you can convert any quantity in meter or mm per kg per second. uh, Thank you for watching this tutorial, and for more detail of any CFD related, please subscribe this YouTube channel. Thank you.